If a seed is planted and it has an 80% chance of growing into a healthy plant, if 8 seeds are planted, what is the probability that exactly one does not grow? One way to think about doing this problem is turning this into exactly one success. So let's say that we need to find then the success of one not growing. Well, if it has an 80% chance of growing into a healthy plant, then it has a 1 minus 80% chance, or a 20% chance of not growing into a healthy plant. So let's find this by doing the probability of one success, where a success is not growing into a healthy plant. And we'll use our binomial probability distribution here. So n will be the number of seeds. Let's see, the random variable x will be 1. The probability that we have one not growing will be 20% chance. And that means that the probability of the complement of that, 1 minus 0.20, is 0.80. Okay, now remember, we're going to plug it into that big formula we have for binomial distribution. So the probability of one success is n factorial, so 8 factorial, over x factorial times 8 minus 1 factorial, 0.20 to the number of successes, which is 1, and 0.80 to the 8 minus 1. Okay, let's clean that up a bit. So 8 factorial, remember, is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 1 factorial is just 1, and then 8 minus 1 is 7, so 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 0.20 to the 1 is just 0.20. And 0.80 to the 8 minus 1 is 0.80 to the 7. I love factorials. So much cancels here. The 7s, the 6s, 5s, 4s, 3s, 2s, and 1s all cancel. So we just are left with 8. And our 0.20 and our 0.80 to the 7th. When we plug this into our calculators, what we get is, rounded to 3 decimal places, 0.3355. That is the probability that exactly one plant does not grow.